Hi everyone, welcome to today's video. This is a continuation of the previous tutorial where we had demonstrated how to dissolve static meshes with multiple materials using Niagara particle systems. In this video, we are going to use Unreal C++ to add further customizations to dissolving each material section independently. For this, I'm going to use this custom struct where we are going to set the material sections to dissolve as well as the delay duration, the custom Niagara FX and the runtime float curve that we can manually adjust for a given material section. So let's get started. Previously we had built a transition component blueprint. First we need to extend this functionality in C++ where we are going to add more precise control over the mesh disintegration process by allowing each material section to disintegrate independently. First, we are going to create a new C++ class of the type actor component. Let's name this as mesh transition component. I'm going to define a custom struct that will hold all the necessary properties to control the dissolve effect. So first we will define a float property for the delay. This will add a delay before a material section starts to disintegrate. Then we will add a U property for the duration, setting a default value of maybe 10 seconds. We will also include a custom float curve for controlling the dissolution rates. And we can also include the Niagara system asset that is going to spawn when this particular material section is being disintegrated. And I will add a crucial property that is going to specify which section to dissolve. And it is going to be an array of int32 representing the material section indices. I will also add a parameter to dissolve all the materials at once. When this is set to true, the int32 array for the material section indices is not going to be considered because all the material sections will dissolve simultaneously. Now let's add a metadata over here where the edit condition is going to be not dissolve all materials. We also need to define two more variables, but these are non-editable and their values are going to be set internally. The variable b dissolving is initially set to false, but once the disintegration has started, this is going to be set as true. And the dissolve time is going to keep track of the current time elapsed since the beginning of the disintegration. So in the actor component class, I will create an editable U property. And this is going to be an array of the dissolve param struct. I need to store the reference of the current mesh components. So I will just add a mesh component variable. And finally, I'm going to create a function called update dissolve effect and it is going to take the delta time. So this is going to be called from the tick event. It will execute at every frame and this is going to be responsible for changing the material properties as well as the properties for the particles so that the disintegration effects work in sync. Let's rename this array to dissolve params array instead. We will use a loop to iterate through the dissolve parameters array. If the boolean variable dissolving is false, we will initiate the dissolve process by increasing the dissolve time with each frame using delta time. Once dissolve time exceeds the defined delay, then we are going to actually start with the dissolution process. The AI suggestion has clearly made a mistake. It wrote duration over here, but it is going to be the delay variable. Yes, I was saying that once the dissolve time has exceeded the delay, then it is going to start the dissolution process by setting the dissolving to true, and it is also resetting the dissolve time variable to 0 because we are going to again use this dissolve time to track the time elapsed since the disintegration has started. For instance, if the dissolve effect is set to start after 2 seconds, then the dissolve time will increment by delta time each frame, and once it surpasses 2 seconds, the dissolving variable will be set to true and the dissolve process will begin. Once the dissolve process has started, we will update the materials and other related properties. So at this moment the dissolve time has been reset to 0 So this dissolve time is going to keep track of the time elapsed since the disintegration started. So next we will calculate the dissolve alpha. Okay, let me just change this to for each loop instead. It is just a matter of better readability. So I will replace this by params. Yeah, now this looks much shorter and simpler. So the dissolve alpha is going to be the current alpha value that we are setting in the curve manually for a given dissolve time. So it is not going to be divided by the duration. I will remove this. The AI assistant inside your IDE does not always give correct results, but it is still making me write code much faster and efficiently. I think that the U-curve float is not the right variable type that we are looking for here. It should be runtime float curve. But to be absolutely certain, let's first open the editor and check it out. If you want to use this class with blueprints, you also need to make this a blueprintable class. But here I am not going to make a blueprint out of it. In my static mesh actor, I am directly going to add the mesh transition component. So here you have the dissolve param array that you need to set. Yeah, so in the dissolve curve, I'm getting the option to add an external curve. So this is definitely not what I'm looking for. So I will add a runtime float curve instead. Here it will be get rich curve or get rich curve constant, whichever you want to choose. And then call this function eval. This basically evaluates your dissolve curve at a given time. Now you can directly set the dissolve time, or you can normalize the dissolve time provided that you also have to specify the values in the rich curve between 0 and 1. So for convenience, I am just going to normalize this. I will create an alpha that divides the dissolve time with the duration and also clamps the value between 0 and 1. If the mesh is already dissolving, then only this code is going to execute. Okay, so before we make use of this dissolve alpha parameter, let's create a function that is going to spawn the particles to dissolve. So this will take the current dissolve parameters as well as the location to spawn. Okay, first we need to create the Niagara component. So let's use the built-in function from Niagara function library, which is spawn system attached or spawn system location. You can choose either one and pass the corresponding parameters as well. In this function, I also need to pass the parent material that I am already assigning to the mesh. So here I will be creating a new dynamic material that is based on this parent material. I will set the is particle parameter to 1. If you have followed along the previous video, you know that this parameter is responsible for separating the mesh material from a particle material. I need to pass this material as a variable material to the Niagara component. In the header file, we need to create a structure to store our material data. Let's name this as material particle instance. I need several variables. The first one is going to be the dynamic material itself. Next, I will also store the material index. I will also store the reference for the mesh dynamic material. And finally, I am going to store the current Niagara component being spawned. I also need to add a Boolean variable to determine if the particle has already spawned and to avoid respawning. I will create a function to initialize all the material instances before you can execute the update dissolve effect. This is a pretty straightforward function. I want to get all the materials for the given mesh component, and then I want to run a for loop. Here I will be creating an instance of the struct variable that we just declared. And first I want to create the material instance dynamic for the mesh material and store it inside our struct variable. Also, I will set this material as the current material section for our mesh component. Finally, we are storing this struct variable to the material particle instances array. And that is it for this function. We are not yet creating the particle dynamic material because that we are going to do after we are spawning the particle. This mesh component variable is actually not defined yet, so let's do that in begin play. We are assuming here that the owning actor of this component will also be having at least one mesh component. So that is going to be assigned over here. It is static mesh currently, but in the future when we work with the skeletal mesh, the same logic is going to be applied over there as well. I will make some changes to the spawn dissolve particles. I removed the location variable because the location will come directly from the mesh components location. So I only needed to pass the material particle instance parameter. So let's modify the function to make use of these new changes. Instead of location here, I will add the get component location of the mesh component. I will also store the spawned Niagara component inside this parameter. Instead of the parent material, I'm going to use the mesh material that we had created earlier in the initialize material instances function. And finally, once we have spawned the particle, we also need to set the Boolean variable b particle spawn to true so that it does not get respawned. Alright, so when the dissolved all material is set to true, I'm going to spawn the particle. So I will call this function, but this will be called for every material because for each of the material section, a new Niagara emitter component is going to be spawned. And when the dissolve all materials is set to false, I will use this parameter material sections to dissolve. This parameter is where we are manually adding the indices that we want to dissolve. And once it is dissolving, then I need to set the dissolve alpha parameter to both the mesh and the particle material instances. I will again check if dissolve all materials is set to true. And here I'm going to get the mesh material for every material particle instance. And I will set the dissolve alpha parameter. I'm going to do the same for the particle material instance. And when the dissolve all materials is set to false, I will again get all the material indices that you are going to set manually. The rest of the steps is going to be exactly same. I am just setting the dissolve alpha parameter for both the mesh material and the particle material instances. And finally, when the dissolve alpha is greater than equal to 1, that means our dissolution is completed. So we can set the is dissolving parameter to false. And here we need to set the particle spawned to false so that the dissolution gets reset. Okay, so I am back in the editor. I will first test out with dissolve all material set to true. Let me tweak the dissolve curve values. I need to ensure that the time stays between 0 and 1 because that's how I have set it up in the code. And for the dissolve effects, I will add the same effects that we had created in the previous video. Next, we need to pass the triangle data of the mesh component for a given section to the Niagara FX. And this is how I was doing via blueprints in the previous tutorial. If you had followed along, you probably remember this. So we just need to call the same function in here as well. And finally, we need to call the update dissolve effect in the tick event because this needs to be executed every frame. And also, since I am calling the function spawn system at location instead of spawn system attached, I need to manually attach the Niagara component to the mesh component. Alright, so let's try this out. This should work now. Okay, it's working, but the issue is the material is probably not assigned correctly because I can still see rectangular particle shape. So here I was creating a dynamic material instance for the mesh based on the base material. I am again creating the particle material based on the mesh material as parent, which is now a dynamic material. So we are having a bit of a situation here where we are creating a dynamic material out of a dynamic material. So to fix that, I'm going to use the same base material and create the particle material instance also here itself. And this line where I'm setting the is particle scalar parameter value can also be directly added over here. These two lines are no longer required. I will delete them. Yeah, now it is perfect. You can see the circular and colored particles as well. Now let's uncheck the dissolve all materials and I will manually add the material ID to dissolve. Yeah, awesome. Only the first material section is dissolving. Okay, so now let's add one more index, index 2, and I will also add a bit of delay and reduce the duration. Let's see how this goes. It is not immediately dissolving now because I have added a delay. Alright, you can see two of the spheres have dissolved. There were four initially, now there are only two. Let's add some more dissolve parameters in this array. So I can have different section indices, different delay time as well as different durations over here. So here the particles are not quite visible when the second set of material sections are being dissolved, and the reason can be that the durations over here and the particles loop durations are not quite in sync. So I'll just convert the loop duration of this emitter into a variable. I'm going to adjust this variable directly from the C++ code. Alright, so this is working fine. The entire mesh is correctly dissolving and the particles are also clearly visible now. I will now try to dissolve this mesh. So I will add the mesh transition component here. The BP transition component that we had created in the previous tutorial is no longer required here. So I will remove that. Now we are going to tweak the dissolve parameters a little because this mesh has only three sections. So first I'm going to dissolve the first and second section, and then I am going to have a 4 seconds of delay and dissolve the third section as well. Alright, so this is working as expected. So here I'm seeing some issue where this section is getting auto reset while being dissolved and again starting to dissolve from the very beginning. And that might be because I have missed a line over here. When the dissolve all materials is not set to true, then also I need to set the duration. So let me correct that. Actually, the duration is going to be constant throughout and does not need to be set in the tick event. So let's do one thing. I will just set it when the Niagara component is being spawned. So here I have also increased the delay by 10 seconds. So the third material section is going to get dissolved after 10 seconds. Yeah, that is perfect. Alright, so that's it for this tutorial. If you're just starting out with Unreal C++, I hope this was not too much daunting for you because I tried to make this tutorial as beginner friendly as possible. And if you want to download this project with the C++ source code, this is currently available on my Patreon page. So consider supporting me by becoming a member. The link is given in the description. And finally, don't forget to like, share and subscribe to my channel for more such tutorials like this one. I will see you in the next video.